Greetings, everyone. Welcome to another Scratch programming session. In this session, we're going to see the part two of the chaos game programming. And I'm just going to quickly remind you what it is. Imagine you have three targets, A, B, and C, and you pick a random position, random starting position, for example, here. And you randomly pick either A, B, or C, and wherever you are, you go half the way towards in that direction. So if you do this simulation a number of times, you're going to start seeing a pattern. And if you do this a lot, thousands of times, the famous Sierpinski triangle is going to emerge. So what we're going to learn in this session is how to program in Scratch so that you could do this randomized simulation. In order to do that, I'm going to first quickly review some algebra and geometry formula that you may or you may not remember. So imagine that I have my initial point here designated with the coordinates x comma y, and my target, for example, is at location x1 comma y1. Imagine I wanted to construct the midpoint of this. It is an algebraic formula, you may recall, that the coordinates of the midpoint is given by the average of the x's, comma, the average of the y's. This should make sense that the x's and the y's get averaged. I want to show you an alternative way of writing this formula. This distance here is the difference of the y coordinates. So if you add to the y value half the distance of the distance between y and y1, you could actually express the average of the y's in this fashion. And you could do the same thing for the x's. The average of the x's is the x coordinate of the original point, and then half the distance between the two x values. The reason for this alternative representation is it allows you to generalize the chaos game we're going to study very nicely to different approachment ratios, etc. Alrighty, so let's get to Scratch. So I want to now go to www.scratchmit.edu. If you don't have an account, please create an account. And once you have an account, you hit the create button. And what this will do is it's going to create an editor here. The editor will come with a default Scratch cat. So what I'm going to do is I'm going to go to the scissors tool, which is a tool to delete things. So I'm going to just get rid of that. Okay. Now what we want to do is we want to create our targets first. So what I do is I go to the new sprite option here. And what I want to do is I want to create it myself. So what I'm going to do is it says in the middle, paint new sprite. So I'm going to select that option. And what I'm going to do is I'm going to have a little circle here that I'm going to color. I'm going to fill it in as red. And it's very important that these objects are centered properly. So when you click on the right corner here, there is a centering tool that appears. So what I'm going to do is I'm going to try to make sure that the center of the object is exactly where I want it to be. Okay. Now I can go into this space and I can move this like that to the top. Okay. So this is going to be one of our targets. If you don't like the size of this, it looks a little bit too large to me. There's a shrink tool at the corner here. So what I'm going to do is I'm going to go to the shrink tool and I'm going to click on this several times until it is small. This is probably a good size. I'm going to double check that my centering, it's a little bit off centered now, so I recenter it. Okay. Now let's go to the info here and let's actually call this one T1 for target 1. All right. Now you could do this process again. Or if you press the shift key and click on the sprite, there is a duplicate option that appears. So what I'm going to do is I'm going to actually duplicate this, and it automatically named it T2. What I'm going to do is I'm just going to color T2 blue so that I have this guy right here is as blue color. Okay, and actually, yeah, it doesn't matter. We could rearrange the letters later, but let's actually do this. Let's make this back red. And what I want to do is I want to actually go to the T2 and I want to color that to be blue. Okay, and I'm gonna move this to the corner here. And you got the idea. We're gonna do this one more time. Press Shift and press T2, duplicate. Click on T3 and let's color that green. And I'm gonna put that at the lower right corner. So these are gonna be the 3 targets that we have in our simulation. Now I need to create another sprite, and this is going to be the sprite that is going to be traveling all over the place. So I'm going to go again, paint new sprite. Let's make this square shape. So I press the Shift key and I grab that, and it is, let me do that again. So I go to the black color here. I'm going to press the Shift key to get a square, and I'm going to paint inside of that black, and then I'm going to make sure that it is centered properly. And then the size again is too large, so I'm gonna make it smaller. I'm gonna shrink it a little bit, and later we may have to shrink this even further, but right now I'm gonna make it small like that. Again, check that things are centered properly. Okay. Alrighty, so we are ready to endow this sprite, the square shaped sprite, with the characteristics of how to move as the random process unfolds. So to do that, I make sure that I'm in the Sprite 1 menu. I go to the Scripts, and now I'm going to put some coding here. Almost all of the Scratch programs that I'm aware of starts with the events when the green flag is clicked. So we're going to start with that. And I personally like to put a clear option. So I go to pen and then select the clear option here so that any drawings we do while this is in session, the next session starts, everything is going to be cleaned. So what we need to do is we're going to create a random process here. So to be able to do that, what I'm going to do, and this is a pretty advanced coding feature, you go to Data, and the data allows you to create a variable. So I'm going to create a variable, and I'm going to call my variable random. And you could leave it as the defaults. What this random variable is you're going to assign a value, and this variable is going to hold on to that. Alrighty, so we are ready to start generating our simulations. Now let's go to the controls and let's put there a repeat option, and I'm going to initially have this go for 100 times so we can see what happens in 100 times. So select the repeat option, so it's going to repeat 100 times. And what we're going to do is we're going to have conditionals in a minute, but before we can do that, let us set the random variable that we have. Let us set the random variable. So I go to Data, there's a Set Random option. And what I'm going to do is I'm going to randomly select, so go to Operators, pick Random. I'm going to select 1, 2, 3. So there are 3 possible targets to go. So I'm going to say randomly pick for me the number 1, 2, or 3. And what we're going to now do is we're going to have conditionals here. If 1 is selected, what happens? If 2 is selected, what happens? If 3 is selected, what happens? So I'm going to select an if then else option. Because it's going to have three options, I'm going to embed into the else one more if then statement, so that means we have three branches. Okay, so now we are ready to decide what happens if 1 is selected, 2 is selected, etc. So we go to our operators, and it says if equal sign. So I'm going to say if the random value I selected equals to 1, what should I do? Okay, and then you do the same thing again. If the random value I selected is equal to 2, we're going to tell what it should do. And then you could have another if statement there, but the else, the third possibility, is really the number 3. So you don't have to put there a conditional. It will automatically be covered in the else. Okay? And now we're going to see what happens if 1 is selected. We need to teach the computer to go half the distance between where the square sprite is towards the red target, which is target number 1. Okay, so the way we do that is we're going to say, so let's go to motion, and there's an option there to say, let's see, it says go to set my x value to, set my y value to. So we're going to change the x and y coordinates of the sprite according to the formulas that we have just studied. So this is how the x is going to change. This is how the y is going to change. Okay? So the way I do that, I go to the operators again. It's a lengthy operation, so I'm going to grab first of all, so let's see how to do this. So I'm going to put a plus sign here, and then I'm going to put a multiplication sign here because we're going to multiply with a half, and then I'm going to put a subtraction sign here. Okay, so what we're going to do is we're basically replicating this formula here. X plus a half, 0.5, times the difference of x1 and x. Okay, so we're going to replicate that. To be able to do that, I go to and find in the motion my x position. It says find my current x position and add to it 0.5, half of target 1's x value. And you can find other sprites xy values in the sensing block menu. So I'm going to scroll down here, and it says find the x position of, oops, I accidentally got rid of the subtraction, so I have to do this carefully. I'm saying find the x position of target 1 and subtract from it. So I go back to motion, I go back to x position. So I'm saying basically take my x position, add to it half the difference between target 1's x position and my x position. By doing that, you're going to make sure that you're going half the way towards target 1. And if you think about it, the y situation, the position is going to be set in a very similar fashion. So what I'm going to actually do is I'm going to click on the, I'm going to shift click on this thing here. I can actually duplicate that. I don't want to write the whole thing again, but I have to obviously clean up things. I'm going to get rid of the y positions, x positions, and I'm going to put them y positions. So y position goes here, y position goes there, and you got to make sure that instead of the x position here, you select the y position of target 1. Okay, so if you look at this carefully, you're going to realize that it is identical to what we have done here. So it is basically saying find the midpoint towards the x, towards target 1. In the x direction, find the midpoint towards target 1 in the y direction. This is what it does. I could do the whole thing again, for when random value is equal to 2. But again, what I'm going to do is I'm going to shift click on the blue option here, so it will duplicate the entire thing for me, and I'm going to put it right here. And all I'm going to do is now the target is not target 1 but target 2. So I got to make sure that these values are changed. And again, what I'm going to do is I'm going to do it again. Shift click on this, duplicate, put it in the last option where it's as else, but now select T3 and T3. Okay? So what we have done is we have created a situation where we are going always half the distance towards the selected target. Now, this will make sure, let's actually run this so you can see what's going to happen. This is going to just go all over the place about 100 times, but what it doesn't do is it doesn't leave any traces. So what might be a good idea at this point is go to the pen, and what we could do is we could say, let's have the pen so at the end of this process, just before you do the next thing in the repeat loop, so you put the pen down, so it puts a dot, and then you put the pen up. So that just makes sure that you are just drawing a dot and then moving on. So let's see how this is gonna do. It's hard to see, but it's leaving some dots. So let me do this actually 1,000 times, and let me do this in turbo mode. Turbo mode, you might remember, is you press shift and then the green flag. When I do that 1,000 times, I got that. Let's try actually 10,000 times. Hopefully this will be a little bit better. Yep, you can see this Sierpinski triangle emerging. Now, one thing we haven't done is we haven't assigned this initial point a random starting point. So you could do that either by yourself manipulating and deciding where to start, or you could say, let's have the initial, so after the clear, you could say, go to a random x value and a random y value. So go to x, pick a random value for x, pick a random value for y, and if you study the coordinates here, the lowest and the highest x values are negative 240 to positive 240, and the y values go from negative 180 to positive 180. So I'm just going to put these values here, negative 180 to 180. So that will make sure that we initially have a random starting point. Okay? If you don't want this to be so fast, you get out of the turbo mode, but again, shift clicking on it. And this will just run it much more slowly. And you're going to see after a while some dots emerging. And I'm going to speed it up again, and you get this famous Sierpinski triangle. Now, you might wonder why I decided to go with this formula as opposed to the good old averaging formula. The reason I did that is if you ever wanted to change the approachment ratio from 1/2 to, let's say, 1/3 to 1/4, or any other value, you can now edit these values here. The 0.5 could be replaced with anything else you want. Okay? So one thing we could do is actually, let's do that. We could go to data and make a new variable. Let me call that variable ratio. So what I'm going to do is I'm going to create a ratio here, and initially I'm going to set the ratio to let's say 0.5. Okay, but what I want to be able to do is I want to be able to change this ratio to anything I want and see how the simulation is evolving. So everywhere I see 0.5, I'm going to put ratio, 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 And this way, you will at the beginning, you could decide what the ratio of approachment you want it to be. Let's check that this still makes sense. Yep. If it is 0.5, you get the Sierpinski triangle. Now, if I shift click on the ratio option here, and by the way, if you uncheck this ratio here, it will not show. If you click on it, it will show again. If I shift click on that, there's a slider option. And the slider in this case goes from 0 to 100. And if I right click on that again, you can set the minimum and maximum slider values. The minimum should be 0, the maximum should be 1. We want a ratio somewhere in between. Okay, so what I can do, and let's make sure, I wonder if I can set up a value here myself. It's not allowing me to enter a value between 0 and 1. I thought I should be able to change that, but we can always change the value of the ratio at the beginning. So let's actually stick with that. So let's see what happens if I change this ratio to 0.25. So when I run the simulation again, you get something like this, which is what you may have expected in the first place. That there's going to be sort of traveling all over the place and filling up space. But now let's say what happens if it is 0.75. If the approachment ratio to the targets is 0.75, observe the targets are, in a sense, attracting the Sierpinski elements towards them. Just to see something in between 0.6, you can see the Sierpinski triangle is beginning to unravel. When you put 0.9, you're going to notice you practically attracted all the Sierpinski points towards the targets. Okay? So let's put it back to 0.5, which is the good old simulation. And here is the Sierpinski triangle. Alrighty, so I hope this was fun and it made sense. It requires some thinking. It is not obvious at all why this simulation creates the Sierpinski triangle. This is a good thing to think about, ponder upon. But what is actually even more interesting is how you can generalize the chaos game with 3 targets. You could imagine all kinds of possibilities. What happens if you add 4 targets, 5 targets, 6 targets, and so forth. You could wonder what happens if you went to the 3rd dimension, if you were playing this game in the 3rd dimension with the cube and so forth. So what I'm going to do is I'm going to quickly show you a couple of these things that were simulated. So I'm just going to show you what happens if you were simulating this for the pentagon. And I believe the pentagonal case, I have a simulation of that on YouTube. So here's what happens when you simulate the chaos game using 5 targets. Again, I'm going to put it on the turbo mode. And you get a very similar shape but to the Sierpinski triangle, but this time it utilizes 5 targets. You could also wonder what happens if you played the chaos game in more than 1 dimension. So here is an example, the chaos game on a tetrahedron. Hard to see, but if you play this on a 3-dimensional tetrahedron, it's basically a pyramid, you get these. This is the shape that you get, which is called the Sierpinski pyramid. And if you played it on a cube, you get a shape that looks like that. And again, it's best to see things in 3D in motion so our brain can process it better. You get the Sierpinski cube, sometimes called a sponge. Okay, So the sky is the limit with these things. I hope this gave you some insight how to get started with these explorations. Uh, Take care.